Find the number of ways 66 identical coins can be separated into 3 non-empty piles so that there are fewer coins in the first pile than in the second pile, and fewer coins in the second pile than in the third pile. Therefore, in this case, we denote the first pile by X. That means the first pile, we denote it by X. There are X coin. And then the second pile, we denote it by Y piles. All right. And then the third one, or the third piles, is actually Z. All right. Yeah. Okay. And the idea here is that X plus Y plus Z is equal to 66. And take note that each piles must have at least non-empty, right? That means each pile must have at least one coin. Therefore, there's a one coin here, there's one coin here, and there's one coin here, right? Therefore, we can put in one coin into each pile first. Therefore, the question is changed into what? The question is changed into X plus Y plus Z is actually equal to 63 because each piles you already put one coin into the respective pile. That means instead of 66, it becomes 63. Therefore, we study this general case first. Without restriction. Without restriction of xy of x being less than y less than z. The number of solution in the positive number in the positive integer is the same as the number of solution in positive integers. In positive integers. Don't need the in positive integers. That means all the x, y, z are actually positive integer is the same as the number of solution to x, y, z equal to 63 in non-negative integers. Because the original question x, y, z must be positive integer, right? But we changed the question into x, y, z in non-negative integer. Because I already said we put one coin into each pile first. All right, and can you see that I'm not solving the original question now. I'm without restriction. That means in this case, we do not need to, we are not considering a case of x is less than y and less than z. Then later we restrict it to x is less than y less than z. Okay, and then what is the number of solution? What is the number of solution? Number of solution in this case, it is actually 63 plus 2 choose 2. Then you will get 65 times 64 over 2. And you will get 65 times 32. Okay, let me explain how do you get 63 choose 2. Explanation. Explanation of 63 choose 2. 65 choose 2. All right. Okay, that means in this case, basically the coin are identical. Therefore, in this case, you have actually 63 coins, right? And what you need to do is put in 2 bar. Suppose you put here, and then it becomes pile number 1, pile number 2, and pile number 3. And it also, can you see that? Then it is actually a permutation of 65 objects. 63 coin plus 2 bar, and can you see that there are this is actually 65 factorial divided by 63 factorial, and then divided by 2 factorial, because the 2 bar are the same, identical. That means the 2 bar are identical, and then all the coins are actually identical. Therefore, what you get is actually 65 factorial divided by 63 factorial and divided by 2 factorial, and that is actually 65 choose 2. And can you see that actually the 2 bar can be like this, can you see that it can be like this? Because what does it mean? That means the first pile you got no coin, 0 coin, second pile 0 point, and then the third pile is 63. It's possible, right? Because don't forget that we already fulfill the criteria that the first pile, second piles are non-empty, because you have 1 coin here, 1 coin here, and then you have one coin here. And suppose you have a 0, 0, 63. What does it mean? That means the original questions, these questions of having positive integers is actually 0, 0, 65, 66. All right. But again, we have not answered this question, because this question require the first pile, the number of coins in the first pile is less than the number of coins in the second pile, and the number of coins in the second pile is less than the third pile. I have not answered this question yet. Yeah. Okay. Now we consider the case. Now we are trying to answer the questions given. Suppose I assume that the first pile and the second piles are equal in number. That means x is equal to y. Then what do you get? You will get 2x plus z equal to 63. And don't forget that x and z must be integers. Must be integers. And must be positive integers, right? Therefore, in this case, can you see that we can consider, that means this implies what? This implies that z must be an odd number. Z is equal to odd number. Right? Therefore, you consider 0 to 63. How many odd numbers are there? 0 to 63, you have 32 odd numbers. All right. Therefore, in this case, number of solution here, number of solution is just equal to 32 solution, right? Then you can also consider x is equal to z. Similarly, number of solution is actually 32. And then finally, we consider y is equal to z. Number of solution is also 32. All right. And then one final case, x plus y plus z. X is equal to y equal to z. Everything equal. Therefore, in this case, x is equal to y is equal to z. Then you have one solution. One solution, right? Okay, therefore, the number of ways whereby at least, therefore, number of solution where at least two of the variables are equal. Two of the variables are equal. Are equal would be just equal to what? Would be just equal to 32 times 3 minus 2. Minus 2, why minus 2? Because this case appear in all the 3 cases. Therefore, you must take away 2 cases, right? So that you don't double count. All right. And therefore, what is the required solution? That means the answer to this question, whereby the number of coins in the first pile is actually the fewer coins in the first pile than in the second pile, and fewer coins in the second pile than third piles is actually this answer, which is actually 65 times 32 minus away all these cases. Minus away all these cases. Minus away all these cases. Therefore, required solution is actually 65 times 32 minus away 32 times 3 minus 2. But the thing is, you divide by 3 factorial. Why 3 factorial? Because every time you consider x, y, z, it can be the order here this is an unordered pair, right? But the thing is, but what we want is actually an ordered pair. Or therefore, in this case, can you see that there are permutation among themselves? Or the number of permutation of x, y, z is actually 3 factorial. Or therefore, in this case, you have to take away this permutation among the x, y, z. All right, and in this case, what you get here is actually okay, 32 times 65, and then minus 32 times 3, and then plus 2. Therefore, again, bear in mind that you do not have the calculator. Therefore, we can use a little bit of calculation. That means in this case, can you see that this part here? Okay, 65 and minus 3, right? Therefore, is actually 32 multiplied by 62 and then plus 2 divided by 6. Therefore, again, can you see that this part, this part you can actually do this because you want to divide by 6, right? Therefore, I can split this into 32 times 60 and then plus 32 times another 2. That means your 62 is split into 60 and 2 again, right? And then plus 2. Because we know that 32 times 2 is 64. And then 64 plus 2 is actually 66. Therefore, in this case, divided by 6. Therefore, can you see that this is 32 times 60 plus 66 divided by 6. Therefore, in this case, can you see that is 32 times 10 plus 11. Therefore, that will give you 331. That will be the answer. Yeah.